Hi, welcome to this presentation on understanding and utilizing tape effectively in your Spectrum Protect environment. And we'll be looking at this from the version 8.1.5 and below. So tape has been an integral part of Spectrum Protect since its inception, and it will continue to be an integral and important part of our storage hierarchy. When we look at tape, tape can be utilized as a primary storage pool. And in this case, you have your data that's perhaps from databases, perhaps from mail servers or other applications, perhaps as file server data, and it's being written out and being stored on tape. And we'll call this our primary storage pool because your primary copy and any extra versions are being kept out there. And this is done just with a simple policy destination assignment for that node. You can also use tape as a copy storage pool, meaning your primary copies are either being kept on a different type of storage, maybe disk, maybe additional tape. You're creating a second or third copy to be stored on tape, and perhaps that tape will even be taken off-site or sent to a different location for safekeeping. And this is done with a backup storage pool command. And copy storage pool is used for our traditional storage pools like disk or file or tape copies. We also have the command protect storage pool, which is for our new directory container storage pools. And it allows us to copy deduplicated data out to tape so that we do have a secondary copy if something happens to your primary directory container storage pool. There are other utilities inside of Spectrum Protect that also utilize tape. For instance, our database backup of our metadata catalog, which is DB2 database, can be done directly to tape. Our import exports, if you wanted to export data and move it on to another Spectrum Protect server, you could utilize tape as your export media. Or our backup sets, which used to create a standalone self-sufficient copy of your data. Backup sets aren't used as much anymore and are not supported with containers, but they still are available. So let's take a look at the capabilities around tape and Spectrum Protect. Your production machines can be backed up directly to disk, so we can do a disk-to-disk backup, and then we can set up policies that will then migrate that data out to tape. And so we call this a disk-to-disk-to-tape type of backup scenario. We also support where you would originally back up to disk, and then you would migrate it to tape, and at the same time you would probably create a secondary copy to tape, which would be taken off-site. These off-site copies are usually stored in some type of Iron Mountain for disaster recovery purposes. Now, with all of these disaster recovery copies that are taken off-site, we do rotate them as needed and utilize a concept of reclamation that we'll talk about here in a bit. We also have the ability to back up directly from your production machine's disks to tape, and then take that tape, create a copy of it, and that copy is then taken off-site to disaster recovery. So lots of different architectures on how you can get the data initially to tape, whether it's first backing it up to disk, then migrating out to tape, whether it's migrating it to tape and creating a secondary copy, or whether it's backing it up directly to tape and creating a secondary copy from there as well. So Spectrum Protect does support a wide array of different types of tape technology. And tape is basically an abstraction layer in the Spectrum Protect server. And so the I/O primitives to support the tape are mapped to the vector calls supported by each of the device types, whether it's LTO, JAG, or something else. And if you want to see a complete list of supported devices, I've put the URL down here. So Spectrum Protect does see tape as an important entity for the data protection. I know with the talk of cloud, sometimes tape gets lost, but we see the value of it in many different ways and are continuing to develop, test new types of tape devices, and continue to add to our support list. When we look at the I/O being written out to tape, what happens is you'll have a thread and this will be communicating with the Spectrum Protect client. And the server will create a little data buffer, and we're going to fill it up until it's full or until that thread ends. At that point, when it's either full or ended, we'll take a second thread and that data buffer will be written out to the drive. So when we look at buffers, they consist of a tape header, a frame header, and then the actual data. And so the data is usually 256 KB. However, if it was an older Spectrum Protect server, you may see smaller buffer sizes out there, maybe 64K or 128K. And this buffer size is negotiated based upon the device, but most modern tape drivers are writing with 256K block sizes. Now, in the future, as tape technology changes, as it behooves us performance-wise to change that buffer size, you will see us to continue looking at what makes most sense for Spectrum Protect in writing out different buffer sizes. When you're setting up the libraries and drives inside of Spectrum Protect, the first thing you're going to do is define the library. And here you can see we have a library defined. One thing to consider, though, is if you do have multiple Spectrum Protect servers that are SAN attached, you might want to have that library shared amongst those multiple Spectrum Protect servers. In the case that you're sharing the library, one of the Spectrum Protect servers will act as the library manager, and then the other servers will be the library clients. And in fact, in this case, you can see that this library is actually managed by a easy server, and so in this instance here we have a library client. Once the libraries are defined, then you'll define the tape drives inside of the libraries. We do have support for different types of drives inside of one library. You can check out our support table to see which combinations are allowed. And then finally, we have the actual volumes which sit inside of the library. And volumes are usually checked in as scratch, and usually they're auto-labeled using the barcode as the label. However, you can check them in as private if you choose, or give them a specific label if you so desire. For SCSI and VTL libraries, you can run this perform LIBACTION command, which will simplify the defining of those drives and paths to the drives by going out and doing a SAN discovery to detect things like serial numbers and WWNs to automatically define those drives and paths to the Spectrum Protect servers. This is not only a helpful command for doing definitions, but it can also be used if you want to delete off tape drives that are associated with the library. We do have the ability to write LAN-Free out to the tape drives, and this is especially of interest to Spectrum Protect clients that host either large databases or applications that want to be able to stream the data to the tape libraries. And so in these cases, we will have a storage agent, and this storage agent can be either installed directly on the same machine as that application is running, so maybe your production database machine or your production mail machine. And when we do the I/O, the buffers are actually occurring on that storage agent before writing it out to the actual device. Now, the meta information will still be sent over the LAN to the Spectrum Protect server and written into our Spectrum Protect database. But the data itself will be streamed directly to tape, and obviously the Spectrum Protect server will be coordinating with the storage agent to make sure that the right drives and right volumes are allocated for that backup or restore procedure. You could also have the storage agent sit on its own machine and then have multiple application servers connect into it. And then that storage agent would send LAN-Free the data to the actual libraries and drives and the metadata across LAN to the Spectrum Protect server. Spectrum Protect has a wide support for different VTLs. Virtual tape libraries are known for being able to offer up hundreds of drives for the backups. And a volume is basically going to be leased to a single user or session for that read-write operation. Now, the optimization to drive selection and the management is going to be based on higher volume counts, and you'll get additional optimization, for instance, if you're using the VTL for multiple Spectrum Protect servers, and this becomes especially interesting if you are counting on the VTL's dedupe capabilities. As you saw on that query library output that I showed a few slides back, we do support shared libraries, and what this means is that you can have one SAN attached library being utilized by multiple Spectrum Protect servers. You do have to crown one of your Spectrum Protect servers to be the library manager, and that library manager is then going to hand out permissions to the different library clients and storage agents to utilize the drives and volumes. The library managers and the library clients are connected via the define server commands, and then obviously you will define a library on the library client and let it know that it's being managed by a specific library manager. You can limit the number of drives that a library client utilizes with the mount limit command. And so the nice thing about utilizing shared libraries, you'll be able to better utilize the expensive library resources, and you'll be able to keep those drives busy by sharing them out amongst all these different Spectrum Protect servers or storage agents. Depending on the type of libraries and drives you're using, there's other options that you can enable. One of those is logical block protection. Logical block protections works with SCSI libraries and drives that support it. And what it does is that the Spectrum Protect will insert a cyclical redundancy check called a CRC value at the end of each of the logical blocks of data that it writes out to tape. And then the drives will validate during the read and write operations, and Spectrum Protect server will validate that during its read operations. That makes sure that none of the data was corrupted when it's written out to the drives. Logical block protection can be turned on at the device class level with the LB protect option, and you can set it as either read-write or as write only. When it comes to encryption, there's two types of ways to achieve encryption on tape. The first would be to have the Spectrum Protect server encrypt the data prior to writing the data out to the drive. And in this case, the Spectrum Protect server will be responsible for not only doing the encryption, but also for managing the keys. When it goes to read the data off of the tape, then it will decrypt it using the appropriate keys inside of the Spectrum Protect server. We also have drive managed encryptions for the specific tape drives that do support that. For LTO, that's going to be your Gen 4 or greater or your 3592 drives. And the drives itself will perform the encryption, and the drives will actually request that key for encryption from the key manager for both writes and reads. For organizations that require data to be written to two places at the same time, called a Simultaneous Write, Spectrum Protect does support that. And so what will happen is that the backup client will push the data to the Spectrum Protect server, and the server will then write that out to two locations. Perhaps that's two different tape devices, as you see here, or perhaps that's one disk device and one tape device. It can be set up to meet the end user's requirements. The important thing to remember here is if you do use Simultaneous Write, the flushes of the individual transactions for the backup are going to be gated by the slowest device. So until the transaction has committed the data to both locations, we cannot mark that transaction as complete. And so it will wait until both of those writes are complete. Thus, if you've got a really slow tape device compared to a really fast disk device, you will see your backups slow down. If you're using a NAS device to do NDMP backups with Spectrum Protect, you have two options on how the data is written. Either the data can be written LAN-free out to a tape library and drives that are either directly attached or SAN attached to the NAS device, or the data can be written across the network through the Spectrum Protect server and then out to any of our storage hierarchy. If you're using the first option to have the filer write directly out to the device, then the library is going to be managed by the Spectrum Protect server, as well as the different tape operations. Now, the meta information will still be sent across the LAN to the Spectrum Protect server and stored in our Spectrum Protect database, but the data is being written directly out to tapes in an NDMP format. And there is a list of specific devices that are supported for NDMP specific backups. So regardless of the type of data that's being written out to tape, the tapes that the data is being written on have a life cycle. And this life cycle is going to be automatically managed by the Spectrum Protect server and the different processes we run throughout the day. When volumes are originally checked into a library, they're usually checked in as scratch. You can check them in as private, and there are some cases for that. But when they're originally inserted, they're considered to be empty. When a process needs a tape, that tape will be marked as filling, and we're going to start at the beginning of the tape and start writing until we reach the end. As long as we have not reached the end of the tape, that tape will still show up as filling. Once we reach the end of the tape, we mark that tape as full, meaning we can't write any more information to it. Over time, data that was written to that tape will expire, perhaps because Spectrum Protect no longer needs that specific version of a file, perhaps because that archive data has expired off. Regardless, you'll end up with these dead spaces on the tape, a space that no longer has valid data on it, but space that we cannot rewrite to. So once a tape reaches a specific amount of dead space, we can do what's called reclaim the tape. And this means we'll take the valid data, write it off to another tape, and then free up the original tape to be, once again, a scratch tape. So once again, this life cycle is completely managed by the Spectrum Protect server, and by issuing query volumes, you can always see which state the different volumes are currently in. When it comes to reclamation, this chart goes over what exactly happens there. So at the top here, you can see when we do our writes to a tape, we write the different tape blocks out sequentially, starting at the beginning all the way until we hit the end of the tape. So over here on the left-hand side, we can now see we have these different tape volumes which are all full. But over time, we're going to end up with dead space on those tapes as the different objects expire. And here you can see we now have gaps on the tapes. So it becomes expensive for a couple different reasons to have tapes that have all this dead space on them. First of all, when you go to read the valid data off of it, your tape drive still has to jump over the dead space, and that takes time. So that will slow down your restores. Secondly, with all these half-empty volumes out there, you need more slots to keep them in and more physical volumes to store the data on. So that's going to cost the organization more money itself. In order to combat these two issues, we'll take the remaining valid data off of a couple of tapes, write that data to a new tape, and then free up the old tapes to be reused. This reclamation process is automatically monitored by the Spectrum Protect server. It works for both on-site and off-site volumes, and it definitely will save your customer money by not having to keep half-empty volumes out there that take longer to restore from. Another option we have with tapes is the concept of colocation. What colocation does is it takes a tape or set of tapes and dedicates it to a specific Spectrum Protect client or group of clients. And the reason for this is then all of that client's data reside on a single tape or set of tapes. So when they go to do the restores, they don't have to jump over other people's data, nor do they have to mount as many tapes in order to complete the restores. The downside of colocation is that you will have more tapes in status filling inside of your tape library. And so there is a little more overhead of additional volumes that will be in the filling status for all of the different nodes using colocation. But colocation is great because it does reduce tape mounts and it expedites your restores. And you can do that for just a few clients or all of your clients, depending on how your organization is set up. Let's now take a look at storage pools and containers and how they use tape drives. The most traditional is having tape as your primary storage pool. We see this a lot where you have Spectrum Protect clients that are hosting either large databases, mail servers, or file systems, and they will be going LAN-free directly to the tape device. A lot of times you also have a lot of parallel processes going, and of course that depends on having multiple drives available. So a lot of times these libraries for these types of LAN-free backups will have 10 or more drives available just to do these LAN-free backups. And not only is this a great solution because it keeps this large workload off of the LAN, but these types of large backups can also really capitalize on performance features inside of the tape drives and libraries. The next instance we'll see is using tape as a copy storage pool. So now we have backed up the data either to a disk storage pool or to another tape pool, and we want to create a secondary copy, usually to be taken off-site for disaster recovery purposes. So the source can basically be any primary volume-based storage pool. So those are our legacy file or tape device classes. And the copy storage pool does an incremental copy of what's new on the primary pool out to the copy pool. And of course, you can have multiple primary pools backing up to one copy pool. Should you have a failure on your primary pool, maybe a tape gets damaged, or maybe a disk goes down, or maybe you have a complete site failure, you can restore from the copy storage pool directly. You can also use the copy storage pool to repair any damages that might have been in your primary pools. With these copy storage pools, these volumes are usually taken off-site, and a lot of times they're taken off by some type of courier. Spectrum Protect is able to track these off-site media. Not only does it know that the volume has been taken out of the library, checked out, it also knows when that volume needs to be brought back on, either for a restore or for reclamation purposes. We can also do additional tracking on that volume utilizing DRM. DRM is built into Spectrum Protect, and it's a process to help you do disaster recovery management. And one of the options in DRM is this move DRMEDIA command, where you can actually give very specifics about where in the offsite process that volume is. Has it been taken out of the library? Is it with the courier? Has it been put into the new vault? Has it been set out of the new vault so the courier can retrieve it? Has it arrived back on site? So each of these individual states can be updated with information specific to each of the volumes. And so what that does, if there is some type of disaster, the administrator can immediately assess, okay, exactly where are my volumes? And if they're not off-site, if they are with a courier, who are they with? Where are they at? What do I need to do to start this disaster recovery process? In a disaster, the other couple things that are very helpful are your device configuration file. This should be backed up and sent off-site as well, and it will be used to bootstrap the device definitions and then used to read the database backup. So this will help you get your Spectrum Protect server back up and running. And then the volume history file is going to be used to determine which database backup to read and restore from. And it's also going to include important information about the restores, for instance, to determine the location of the log files, as well as the backup media that's needed for processing. In addition to taking offsite your Spectrum Protect database backup, your Spectrum Protect copy storage pool volumes, you also want the device configuration files and the volume history files going offsite. With the introduction of container storage pools, the copy out to tape has changed a bit. Remember, when you have a container storage pool, especially in this case a directory container storage pool, the data is going to be deduplicated, optionally compressed, and optionally encrypted. So now, as that data sits in the primary directory container storage pool, we have a couple of options what to do. If you only have a single Spectrum Protect server in your environment, you can create a copy of that directory container out to tape. Now this copy to tape will leave the data deduplicated, and if it's compressed and encrypted, all of that's going to be left the same. And so it's going to be written out to your directly attached tape. And so now you have a copy of your data in the directory container and a copy out on tape. And that could also optionally be taken off-site. If you do have multiple Spectrum Protect servers, ideally you would set up node replication, where the data in your directory container pool will be replicated over to a secondary Spectrum Protect server. So if your first Spectrum Protect server has a failure, your clients are automatically able to restore from the directory pool on the secondary server. Now you could optionally also add in a copy to tape, either at the primary and or at the secondary site as well. And then one other way you could implement this is on your primary server, you could simply replicate the data over to your secondary server and then create a copy of that directory pool out to tape on the secondary server. Some things to consider when you do create a copy out to tape of a directory container pool. In order to create this copy, we use the protect storage pool command with type equals local. And when the data is written out to tape, it is left deduplicated, and if it was compressed or encrypted, it's also left compressed or encrypted. The clients cannot restore directly from that tape. That tape is going to be used to rebuild the directory container if there is some type of damage done to your primary directory container. So let's take a look at that. In order for that tape pool to be used for a directory container, the first thing you'll have to do is make sure your Spectrum Protect server is still up and running. If not, you'll have to get your Spectrum Protect server up and running. And then you're going to need to repair that directory container storage pool from the tape copies. So basically we're copying the stuff off of tape and writing it back into the directory container. And finally, you can then do a restore to your clients. And that restore is coming from the directory container, not from the tapes. So taking into consideration the repair steps that have to first occur against the directory container before we can restore the data out to the client, let's look at some considerations for the protect storage pool type equals local. We'll look at this from the perspective of a small, medium, or large Spectrum Protect server instance, and this is as laid out in our blueprints, and I put the link here. So if you have a small Spectrum Protect server, the protect storage pool type equals local, so making a copy of your directory container out to tape is recommended. It will work, but you do need to plan for disaster recovery time of less than or equal to 48 hours. If it's a medium-sized Spectrum Protect instance, as outlined in our blueprints, then once again, you need to plan for the disaster recovery time, and just kind of be aware that this is probably more suitable for servers that are on the lower end of the medium blueprint range. And if you have a large Spectrum Protect instance, then protect storage pool type equals local is probably not a good fit for that type of instance. The time to recover that amount of data is probably too high. If you do implement creating copies of your directory container out to tape, we strongly recommend that you test your disaster recovery scenarios and prove that the amount of data that needs to be recovered can be done so in the appropriate amount of time. And likewise, the recovery time is going to be directly impacted by the number of drives, the type of drives, and the type of disk that's being utilized for the database and storage pools. In order to optimize or reduce the DR time, you want to look at having higher performance disks along with more tape drives in order to do the restores back to the directory containers. So when you're setting all of this up, you do need to take into consideration the time it will take to do these steps, because unlike your traditional copy storage pool that you would use for your legacy tapes, you're not able to restore directly from the tapes. So let's go through this chart here. And this is comparing legacy storage pools where we've used the copy storage pool versus the protect and repair commands for container storage pools. So the primary storage pools are available at DRSite. This is true for your copy storage pool after you've done the restore storage pool command. And it's true for your directory containers after you've done the repair storage pool command. The client can restore directly from tape copies if it's a copy storage pool for your legacies. If it was a copy of a directory container, they cannot restore directly from tape. The storage pool disk is required at the DRSite. For a copy storage pool, no disk is required. But for a directory container, you first of all have to rebuild that directory container from the tape copies. Data written out to the tapes, if it's a copy storage pool, is not going to be deduplicated, versus for the copy storage pools, it will be deduplicated. And then the time needed for daily copies to tape. For a copy storage pool, we're having to copy over all of the data in its full format. Even though it is an incremental copy, those files will not have been deduplicated or compressed. Versus with a container storage pool, we're only copying over the deduplicated extents that need to be written out. And then finally, the action that has to be done before you can restore any bytes from those tapes. For a copy storage pool, you got to restore your database and make sure your Spectrum Protect server's up. Versus with a directory container, you got to restore your database, make sure your server's up, and then repair your container pool. The other thing to take into consideration with the tape copies of your directory containers is we do reclamation a little bit different. Reclamation will actually be part of your Protect storage pool command. We do not run a separate reclamation process like we do for your copy storage pools. So regardless if you're writing data out to tape as your primary storage pool, as a copy storage pool, or as a copy of a directory container, the great thing about tape is it acts as an air gap. If your environment was attacked by some type of ransomware, the nice thing about data on tape is that ransomware has not yet attacked tapes. One, because it's difficult to figure out which tapes are out there, and two, it's difficult to access them, either because they have to be mounted and written to, or because they are physically not in the library. They may well be sitting in a vault at some type of Iron Mountain facility. Air gap becomes extremely critical when we look at protecting corporate data from ransomware. With it being on tape, we can be comforted that the air gap is going to protect the tapes from ransomware. If your production data was attacked by ransomware, you would still be able to restore from the data that's out on tapes. So just to summarize, tapes are a critical part of Spectrum Protect's backup strategy. Not only do they allow us to protect large workloads and utilize LAN-Free to do that protection, but they also give us a great way to take data off-site in case of disasters and to create an air gap for things like ransomware. There is a tech doc available that goes into a lot of detail about the items I've spoke about in this presentation, so please do take a look at this. This gives a lot of great implementation examples as well as details on the various options I've spoke about. Thank you very much.